Donc je pense qu'on va pouvoir commencer. Merci d'être présent pour cette journée spéciale industrie du futur organisée dans le cadre de la semaine de l'IoT, la semaine de l'Internet des objets. Alors aujourd'hui on va parler de concepts qui sont assez courants et du moins ce sont des concepts dont on parle de plus en plus souvent dans l'industrie, à savoir Profit Energy, Profit Cloud, qui sont des technologies associées à Profinet. Pour parler de ce sujet, on a le plaisir d'accueillir le professeur Philippe Sahay, qui nous vient de l'université de Leuven, en Belgique, et qui, depuis longue date, travaille avec un certain nombre d'industriels en Belgique. Donc il aura un certain nombre de résultats très intéressants à vous proposer. Le travail autour de Profit Energy et Profit Cloud, travail conjoint qui est en partie effectué dans le cadre du projet Interreg des deux mers InCase. Alors pour ceux qui ne connaissent pas bien ce type de financement européen, il s'agit d'un programme permettant à des projets transfrontaliers d'être financés, de voir le jour. Et ici, en l'occurrence, pour le projet Interreg des deux mers, il s'agit de partenaires qui doivent être présents soit dans la région Hauts-de-France, soit les Flandres, les Pays-Bas ou tout le sud de l'Angleterre. Donc aujourd'hui, le projet InCase, dont la signification est Industry 4.0 via Network Control, Application and Sustainable Engineering. Il a un certain nombre d'objectifs, et parmi ces objectifs, il y a le développement, le déploiement et la démonstration des technologies clés d'automatisation pour l'industrie du futur. Et il y a également la préparation des ingénieurs pour les usines interconnectées de demain, les bâtiments intelligents et l'ingénierie durable. Donc dans ce contexte, la question de l'interconnexion des sites de production via Profit Cloud s'est posée, et également la question de l'efficacité énergétique grâce à Profit Energy. Et vous allez voir que c'est un sujet qui est absolument passionnant. Et c'est maintenant que je laisse la parole donc à Philippe Sahay, parce que c'est lui l'expert sur le sujet. Donc je vais juste faire un petit changement de présentation, et on va faire un changement de speaker en même temps. Et un changement de langue en même temps, puisque Philippe va vous parler en anglais. Merci Philippe.
Oui, merci. Je vais vous parler en français, mais vous pouvez poser des questions en français. Ce ne sera pas un problème, je crois. Ou j'espère. Ok, merci. Thank you very much. I'll continue in English then. And I'll stay in my corner if that's okay with the camera, because I have 3 things and only 2 hands. So I have 2 short presentations for you. I'll start with Profit Energy, and we'll continue with Profit Cloud in that order. What are we going to discuss here? Some general ideas about energy saving in manufacturing industries. Then what is Profit Energy? How do the commands look like in the Profinet network? And at the end, some measurements, analysis, and the use case. Most of you know the EU 2020 targets. There are many 20%, but these 3 are of concern today. Reduction of the greenhouse gases, probably we will get there in 2020. Producing 20% of our electricity with renewables. Everybody starts to doubt that it's a sign that we won't reach it. But of one thing we are certain, we won't reach this one. Reducing the energy consumption, efficiency increasement, we won't get there. So one of the questions is who's using all that energy, or where are we? Let's start with that. The line, yes. The line going down, that is our real target, -20. If we didn't do anything when we started, which was around 2005, we would have been there. And we are now somewhere here. Nobody really knows exactly, but for certain we're not on track. Who is using all that energy? Well, if you take a look, about 35% is for energy, households, and here services. So we are in this part here. We need a way to reduce the energy consumption of the mainly manufacturing industries. But there are several options. One is we could try to reduce the energy consumption during production. That is here. This is during standstill in the weekend, for example. That is not so easy. First of all, it's not easily done. You need to renew part of your production process, maybe even totally renew. And it's very expensive. We will need new hardware, or you need to develop new processes to produce, etc. Another option is to take a look at idle time when we are not producing. For example, during the weekend, or if you work in 2 out of 3 shifts, the third shift during the night, you're not producing, or during planned or unplanned breaks, we could say, okay, we're going to shut down a machine, a production line, factory. Only when you do that, shutting down is okay, but starting up again, big trouble. Not easily done. Is this important? Well, this is a question that was asked by the German automobile manufacturing companies 10 years ago. They started to measure, and they saw when they were not producing that they were still using 60% of the energy that they used during full production, doing nothing, not producing. Once they realized that, it was a big problem, and they really wanted to do something about it. So it could be quite important. An easy solution might be, I'm going to go through this very quickly. We could say we're just going to shut it down with manual switches. Makes little sense. It's 2017, almost 2018. It's expensive, time intensive. You need people for that. Makes no sense. You could say, okay, let's automate those switches with a new controller, a new PLC, or as you say in French, API, Automate Programmable Industriel. Well, you could do that, but you need additional wiring, additional hardware. It's expensive. You need to program the second controller, and still it's on-off. Nothing changed. So, not so good. I think we need something else, or they thought they needed something else, the German automobile manufacturing. It's going to be Profi Energy, but let's first dream a little bit. In fact, we want something that does this, like your television at home. We need that one. When you're at home, you sit in your couch and you could say on or off and go to sleep mode. And when you bought your last television, you didn't install extra switches. Everything was inside. No extra components, and we can put it in standby, in sleep mode, or powered on. So we dream of something like this. Yeah. That's our dream. Let's take a look at how it could be done with Profi Energy. First of all, what is it? A little bit in the background. It's a profile, just like we have a lot of profiles, in this case in Profinet. What was that? In most field buses, not only Profibus or Profinet, but also the American ones, even the French ones, most vendors agreed on the header and the trailer and how to detect errors in the communication, but they didn't agree on one small thing, the content, the useful content of the telegram they didn't define because they never agreed on it. You can't expect that Siemens and ABB and Schneider and Rockwell agree on the content of a telegram. Impossible. That was, of course, a problem later. So the users decided to push a little bit, the big users, guys like Bayer, BASF, all the big ones. They said, okay, let's discuss, and on a minimum, and we call that a profile. A minimum could be for electrical drives. You need to start and stop. You need a set point for the speed. You need feedback, the actual speed. That one we can agree on. The other 2,000 parameters in a drive we will never agree on between the vendors, but the minimum things we do. That's a profile. You have profiles for weighing systems, for incremental encoders, for electrical drives, etc. Every field bus has them. Well, Profi Energy is just another profile, a kind of vendor-independent agreement on the content of the telegrams. Who wanted that? Well, I already told you, the AIDA group, the German automobile manufacturing industry. Usually, when they ask something, they get it, for certain in Germany. And these are the original ones that started with it. Meanwhile, it's a lot of more people. What they wanted was a standardized multi-vendor way, a kind of modular method to save energy during idle time, only during idle time. So we will need power-saving modes, and we will also measure energy, in fact. The end result should be, I'm going to push here, this was our original picture, production weekend, this is the new one, production, and in weekend we want only this, not this. During our breaks, it should be better. Okay, we have 4 use cases. We could save energy during short planned pauses. A short planned pause could be a break to switch shift, could be a break to eat, something like that, but it's planned, we know it. Or a planned short maintenance in a big plant could be that. A longer pause could be weekend or a night shift. You're not producing during the night, you are 8 hours without production. The third one is a non-desired one, unplanned pauses. Usually when your plant is malfunctioning, you have an unplanned pause. And the last one is measuring and visualizing the energy flow. Okay, well, what we want is, for Profinet, we're focusing on that one. So Ethernet-based, practically real-time communication. We want a uniform, predefined way, cross-vendor, doesn't matter which is the vendor, acyclic communication in Profinet. It's acyclic. We're not going to send over the commands every millisecond. Your normal communication in Profinet, Profibus, in any field bus is very deterministic. You have 1 or 2 milliseconds, you talk to everybody and you start again. Very deterministic. These commands only come every 5, 6, 7 hours, just in between. It's an acyclic command. Going back in my corner. The turning off should be in the device itself, no additional components, just like your television. Keep that one in mind. And it will maybe not only just be on-off or one sleep mode, you may have different levels of sleeping. And the deeper you sleep, the longer it will take to wake up again. Because we need to wake up again. Don't forget that. This is more or less how it looks like. I'm going to see if no, there is no extra text on it. This is production. It's not so very good visible from here, but maybe for you it's better. Here we are ready to operate. We can immediately start, and the yellow ones are 1 or maybe more sleeping modes. This is one you may know from your portable PC. He could be in very deep sleep, but you can wake up on LAN with a special message on the network, and it wakes up. Higher? Okay. It's a heavy thing. It may look like this. You have a conveyor belt, a robot, another conveyor belt. Let's take a look at the feeding conveyor belt. He's producing. We have a break. We ram down to stand still. Then we stay in pause. And, well, if we want to be ready to start producing here, we need to start up the conveyor belt this time earlier. We need to think beforehand on how to start. And as we use extra energy here to ramp up the device, this needs to be long enough, otherwise we're not saving energy. Okay, so we have a minimum length of stay in your pause. It's like with your car before the red light. Could go in a saving mode, but if it's not long enough, you're not saving anything, you're just using up your battery. Well, all those parameters you have to keep in mind, and the good news is that they will be, this is another example, you could read it on the slides, which will probably be available for download. You could read it at ease, but for example, the conveyor belt needs 1 minute to stop, 1 minute to switch on, and we need minimum 2 minutes before we start gaining time. Robot is already a little bit more difficult because starting up will take a lot of time. He needs to do his homing again, probably. All these parameters are, I'm going to go over these, but all these parameters are in the configuration file of your device. You already have that when you use Profinet or Profibus or whatever. You have a GSD file, in the case of Profinet, a GSDML file in XML, and all the parameters of the device are in there. These are just in there too. So the device knows them. They come from the manufacturer. This is not really worth mentioning. How does it look like in the network? Pretty normal. We have a small test to start with. A CPU, API, an I/O device, and a switch, which is in between a normal Profinet network. And if we want to put this device in a sleeping mode, could look like this, but we have other pictures coming. This is more or less the traffic that we put in between the normal Profinet traffic. We give a command to start the pause. The device, this is the controller, API, PLC. This is your I/O device. We give a command to start the pause. He says, okay, I got the message. And then you can say after a while, not so long, are you in sleeping mode? And he will say yes or no. Why do you have to ask? In fact, here we send, in this command, we send the time that you want him to be in pause. And the device itself checks, is this time long enough to save energy? And if not, he's not even going to power off mode. He just stays on. So it's a kind of foolproof thing. You could give him a command and he could refuse it if it makes no sense. To end the pause, it's the same, but vice versa. You get back a confirmation, this will be my time until I'm ready to produce. It's up to the user, of course, to program it in a sensible way. The commands look like this. This is very small. Take a look at it at ease, but I could say that for Profi Energy, as they are acyclic commands, it's UDP/IP. A set of measurements. What could it be? Well, now, 6 years ago, they did a series of measurements at Daimler-Benz and Volkswagen as tests. So we're going to take a look at those. And they took a look at the typical robot production cell. And the goal was quantify what the potential of saving could be. So it looked a little bit like this. You have here a SalleC diagram. I hope you use the same word in French. SalleC, this type of diagram. Robot cell, API, PC, some I/O devices. In total, the robot, for example, uses during production 18.5 kilowatts. In standstill, he still uses more than 6 kilowatt. You could see the difference. This is what it looks like in function of time. You see the peak power goes to almost 90 kilowatts, a lot of variations in it. The mean energy demand is a little bit less than 40, and in standstill, we drew a line here, it's a little bit less than 20 kilowatts. Means that the base load during idle time is about 50% of this. I will come back with some extra figures later on. For them, with their prices of electricity, they came to the conclusion that breaks that are longer than, let's say, 4 or 5 minutes, breaks that are longer than that, for these, it makes sense to go to a sleep mode and save energy during idle time. Shorter breaks makes no sense for them. That's the time of the total break. You don't need the total pause. No. Unplanned pauses is always a problem. Planned pause and no production during a shift is no problem. An unplanned pause, but it's like that in a production line. When you're coupled, somebody needs to take the decision. It's going to be 15 minutes, and everybody could go to the toilet and come back to the plant. Yeah, for unplanned interventions, it depends a little bit. If they guess it's going to be long, then you could still go, but you can't take the risk, otherwise it's true. The figures come back, but we just said that 50% of the total energy is used during idle time. 2 slides ago. The next one, I show it again. Of all those idle times, they said that about 64, so let's say 60 to 70% of savings are possible. That means if you take 60% of 50, this is our energy saving potential. You're not going to gain it all because you don't go to zero, but okay, that's the maximum potential. Let's take a look at it in kilowatt hours and in euros, everything together. 2-shift operation, 2 shifts out of 3. They work 5 days a week, 2 weekend days. Green is what the energy used in that production cell during production. Orange are the planned pauses. It's a lot. Just start thinking. 2 weekend days out of 7. 5 working days, but only 2/3 of it. That's also 1.67 days. We already have 3.67 days doing nothing without shorter pauses. So just look, this is planned pauses. This, unplanned pauses, difficult to do something with it. Potential savings, if you count at 60 to 70%, it's for that small production cell, 114 euros. Is that a lot? That depends a little bit. You get it for free, only there will be still a lot of adjustments to do in your programming software. A lot, depending on the complexibility of your process, but you still need to adapt, of course. Maybe a question. If your company would do that, your communications officer would certainly want to speak about it, but he wouldn't say how much euros you're saving. He would say, how many kilograms of CO2 are you saving? That is the message they like to bring. Anybody has an idea? How many grams or kilograms or I don't know what of CO2 you need for 1 kilowatt hour? Don't answer, Frank. I told you a few weeks ago. No idea? Then it's this. A typical fuel mix gives you, for electricity production, gives you about 0.6 kilogram per kilowatt hour. In Germany, a few years ago, it was this. In France and in Belgium, it's going to be a little bit less because we have a lot of nuclear power and no CO2. I'm not suggesting it's better or worse, but I just give you the idea. You save, keep this in mind, that's an easy one. So much CO2 for a small part of your factory. Some measurements we did very quickly. I'm going to tell you what we are going to do or doing at this moment during the InCase project. We did a quick measurement for this. In between, they came with a test setup for a fast booting industrial VLAN client. So we did everything together. You get the picture as it was while we measured. So it's not so very nice. Usually it's better, but we were working. We just put everything on the screen. This is your normal production, and here we went to a sleeping state for a ET200SP I/O device from Siemens in this case, with only one input and one output module disabled. It's something. What are we doing for the moment? At KU Leuven, but in fact also in Lille, in IF Lille 1 and ICAM, we are, the three of us, setting up a quite large lab setup to demonstrate the working principle, to analyze it, and to determine the typical energy saving potential for electrical drives, IHM I think it is in French, human machine interface, touchscreen, things like that, remote I/O, etc. What we are doing in Ghent, I am from KU Leuven, but Campus Ghent, we have as big neighbor, one of our big neighbors is Volvo Car Ghent, and they just started production of a new type of Volvo. That means with them you totally demolish the production line, you build a new one. And the new one is Profinet, so we're going to measure with them typical ABB robot consumption, larger drives, and we want from them, they agreed to give it to us, typical pause times. It's a little bit delicate, but they even said we don't have unplanned pause, even those are planned, they said. They didn't mean it, but everything is going to be planned, it seems. We want to develop a tool to estimate the energy saving potential. That is for them the criterion, this one, not this one here in euros, to see if we're going to go on. We defined 3 use cases, complete robot cell with them, with all the components, so it's the real thing, a normal conveyor belt and an overhead conveyor belt for internal transport. 3 of them, and we're going to calculate what the energy potential, saving potential is. Depending on the outcome, we're going to see together with them how to change their software routines, because there are a lot of things to keep in mind. But the idea is, if it's okay, we're going to jump in their software and actually change it. We're a little bit lucky. The guy who develops, or the people that develop the standards for that kind of program for Volvo worldwide, works in Ghent, so couldn't be better than that. It's even a former student, that's even more handy. That is part 1, so we could jump to part 2. You know where it is? The questions are maybe for later. Second part is Profi Cloud. We could discuss what is the goal, some application scenarios to give you an idea what could we do with it or not do with it. Then how does it look like, first in schematic and then with some pictures. If we have the time, I hope Frank gives me a sign when it's still something like 10 minutes or 5 minutes. We could say something about security, authentication, and software development, and what we are going to do in the InCase project. Well, the goal is quite clear. We want to connect our factory to the cloud. Seems to be the theme of the day, so that is it. In fact, what we want with this is we want a seamless, secure connection to I come back on the words in a minute, to remote production machines or facilities. And remote doesn't mean 200 meters, then you throw the cable, it's kilometers, tens of kilometers, other side of the globe. But we want to connect to our own remote production machines or facilities, or we want a seamless, secure connection to our products with our clients. We are a manufacturer of production machines. We install a machine in Hong Kong. We would like to see more or less what is happening there. Or you may want to connect to the cloud. It's in the fashion today, so why not? I forgot something. I'm coming back to keep your attention to it. It needs to be secure. That's quite obvious. What do I mean with seamless? We want it to be easy. Not too complicated, preferably without the IT guys of our manufacturing plant. Why would we like that? Because we want to monitor the status of remote production site, or even give some simple commands. We can't command in real time quickly. It's not a millisecond level communication, it's over the internet. But we could imagine something like 400, 500 milliseconds, we push a button and it reacts. It's just to start, stop, or to monitor slowly. The control should be on the other side. It's not our goal. We're not dreaming of what they call now the tactile internet. That is dreaming. I would wait a little bit for that. With millisecond response, it's not for now. This is the slower one. You may want to analyze the key performance indicators, the KPIs of your remote machines, of your production, of your products. You may want to do a kind of long-term slow quality control or gather data for data mining later and you store it in the cloud. Or you could make maybe some data available to your clients, for example, for their predictive maintenance. Why not? Probably somebody told you one of these lectures that we will have to make money in another way. Well, maybe you could sell to your clients when they need to do predictive maintenance. Why not? That could be many reasons why we would like to do that. We want this in this case for a Profinet industrial network with I/O controllers and I/O devices. Why Profinet? Well, it's worldwide since last year the most used one, worldwide of everybody, of all kinds of protocols, and in Europe for certain by far. So we could focus on this one. Let's start with, we wanted it to be secure. Secure means in our case TLS encrypted and authentication. Seamless, well, we'd like to do this in a very simple way in our standard programming software where we already define our network with our I/O devices and stuff. Your standard PLC API programming software. We don't want to go discussing with our friends of IT about firewalls, virtual private network, importing and exporting of variables. No. It's a kind of armed peace between automation engineers and IT, and it's... No, but that's the reality. The IT in a production plant, not in your service thing, but in a production plant, the IT guys are somewhere and the automation engineer are elsewhere. And as long as the field bus system was not Ethernet, it was quite okay. But once it became Ethernet, they both started thinking, oh, and you detect some friction here and there. Anyway, set aside the friction. It's easier to do it without this kind of stuff than with. So we would like to have it in our normal programming software for automation. Okay, well then one solution could be Profi Cloud. It's a solution provided by Phoenix Contact, but it's open to other Profinet equipment from other vendors. And it's also an open cloud. You can host your own software applications there. You can write them yourself if you want. Phoenix Contact is a quite large manufacturer of automation products in Germany. It's if you compare it to Siemens, it's 1/10 or something, but okay, Siemens is a very big thing. But they are quite modern, very, as you don't have a history of 50 years of automation like Siemens, you can easily introduce new things. So they are quite competitive with their products. But it's open to other vendors. What could be the application scenario? Well, one example could be you have a water production plant. You are somewhere based alongside the river. This is your main plant. And you have, it is with us like that in Belgium, in the Ardennes, for example. This is La Meuse. You have a production plant where you insert your drinking water into the distribution system. And you have 10, 15, 20 kilometers further remote wells, production sites, or lakes where you draw up water, do a first transformation, you pump it to the main station, and from there you go on. But the distance is 10, 15, 20 kilometers, something like that. That could be an application that you could think of. Another one might be, I took this one to France, I didn't change it in fact, to be honest. You have some remote, you are a French company, and your main automation guys are in France. And you have production sites in the United States, in Russia, in China, and somewhere in the Middle East. And well, we want to monitor the status of our remote sites. You could think yourself what you want to do with it. You could read it. I'm not going to repeat it because I don't have a lot of time. In fact, you could have devices that are connected to the cloud and then come in with a cloud coupler to your normal PLC API in France. Let's take a look, and there could be devices running in the software in the cloud. Let's take a look at how it should look like schematically. Well, this is France then. You have your API, your programmable logic controller, PLC, and there are two local Profinet devices in your local Ethernet network. You can access them every millisecond, again, very deterministically. And you have in the United States, in China, I forgot Russia, it didn't fit, and the Middle East. You have there also a Profinet device that measures some things of your machine, or you could control some parts. And we want to have them in our network here. This is an easily configurable network. That's for the automation engineer. No need of an IT guy. Okay, well, this is our cloud. You install a cloud coupler. That one connects to the Profi cloud. And we are going to make those Profinet devices now cloud devices, and they are connected. How do they look like to your automation engineer? Like this. For him, it's just a normal local, between brackets, a normal local Profinet network. This is updated every millisecond or something like that. This is updated every 500 milliseconds or whatever. This is not for control, for monitoring or slow commands given by humans. By definition slow. The rest is fast. Or you could say, okay, I want to get some data from services in the cloud. For example, weather data. It's a big company. I have a lot of cooling devices for air conditioning, for cooling. And on top of my plant, there are a lot of coolers. And I want to optimize the energy profile. I need weather data. I need the weather prediction to optimize what we're going to do. It's an actual application, in fact, that is already running in Switzerland. You could take the water from there. In the Netherlands, they program the service to calculate the height of the water on every place. In the Netherlands, it's a little bit delicate, to control their pumping stations. remotely. It's a typical, slow, remote application. Just to give you an idea of what could be there. You could do data logging, ERP data, etc. Again, it's just available as a normal device. How do they really look like? Well, the cloud coupler, there you can't choose for the moment. It has to be Phoenix Contact. If you want a normal cloud device, which acts like I/O, but at a very remote distance, it's also a gray one from Phoenix Contact. But in fact, you could see that, oh, the controller doesn't need to be Phoenix Contact. Could be, I can't read it very well, but it looks like Siemens. Should mention names. Your controller could be Siemens. Why not? Your programming software could also be TIA Portal. It could be another one too. And you just see in your Profinet the cloud devices standing there. We didn't need IT. It's your normal automation network, only updated a little bit slower. When you zoom in, it's almost nothing. You need a UUID, a universal unique identifier for your cloud coupler for every device. These are the two devices you saw here. We added here a coupling cloud to cloud. It's a picture from last Friday when we connected two clouds, one in Ghent and one in Lille. Because everybody has his own clouds, but you may want to connect to clouds, of course. That is available too. You just need to enter once the UUID, configure them, and they are normal Profinet devices. It looked like this. In fact, last Friday we had to do something. Our colleagues from Lille were coming to Ghent. This was the controller we saw 2 slides ago. Here is some Profi Energy equipment. This is the controller that controls the Profi Energy part. And we gave a command here. It went up to the cloud, came back here. He got the message and he put this one in sleeping mode. And in fact, we measured the energy usage, the current in this case, with the cloud device, and that one also went back to there. Just, well, we had to make something compact, so we included both together. 2 weeks ago, I was on SPS Drives, and I was looking for the Profi Cloud setup of Phoenix Contact, and the first one I entered was a separate application on Profi Safe for safety components. Could also be an idea to monitor what is happening there. You can connect to Android devices. You could get a warning on your watch that something is wrong. If you don't want to sleep anymore, I advise you to do this. How much time do we still have? None? But we may have some questions, so I will go through this very quickly then, because there are still 2 points. All the connections are TLS encrypted. I lied a little bit. Maybe you need to discuss with your IT guys that you need to be able to reach the Google DNS server, or you have to set up your own. The first time we tested, it didn't work on campus. We tried and tried, it didn't work, so we said to the guys in Germany, it doesn't work. Impossible. Okay. We took it home, we put on the power, it worked. Back to campus. Then we knew that we had to discuss with our IT friends. We logged and we saw, we didn't know, they didn't document it. It reaches out standard to the Google DNS server. Now, at least with us on campus and in many companies, your firewalls will not allow it, because in our case, they said it would allow students to directly access the Pirate Bay on internet. They didn't want that. Okay. I didn't know. I learned that one. We report they opened it, especially for us. We send the message back to Phoenix Contact. They fixed it so that you can choose your DNS server. So now you're home free. And well, this port should normally be open. But that's the one that needs to be open. Every connection is TLS encrypted. The devices, it's not my time. Okay. The rest is okay. Each device is identified and authenticated using a UUID. It's sent once. Only manufacturer UUIDs are allowed. You can't find out one. And after the first login to the cloud, you get, of course, another key value. It's the typical system that is used in many applications. This is more or less where you are. In fact, the Profi Cloud is hosted by IBM in Frankfurt. Why in Frankfurt? Because Frankfurt is also a financial center, so it has a very wideband, very fast access to the World Wide Web. It's necessary for the banking system. If you want to make money, you should be here. Right services in the cloud. Everybody will be buying them. This is already a little bit difficult. More difficult, you need to develop hardware. That's for IT. This is maybe for electronics or automation. Just to mention. Okay, Profi Cloud, as summary, offers remote control and maintenance using the internet as a network. For the right applications, slow ones. Nobody can do it for the moment quickly over internet, so it's quite easy. It's very easy engineering. The cloud components are very easily used in your local Profinet network. You don't need complex things or a lot of work. It is really very easy once you have access to that DNS server. And you could use components as you like, except for the cloud coupler. There is no second source for that one. Is this the only gateway to the cloud? Of course not. There are a lot. MindSphere from Siemens is another one. Dell has one. Harting has one. General Electric has one. Bosch has one. Phoenix Contact has one. Many others. They are all company initiatives. We are back like the field buses started. Everybody wants to give his customers access to a cloud. You may keep in mind for the next years this one. This is a little bit vendor independent, OPC UA. You already know it for your local Ethernet connection. Combined with TSN networking. Time-sensitive networking is a set of protocols that is already defined by IEEE that guarantees you delivery time. It can't be quicker than quick, but it gives you, it's a complete set of systems of priorities and stuff. You could keep this one in mind. I didn't write it here, but maybe SDN, software-defined networks, could also be something that might be interesting. There are a lot of solutions. What is the outlook for us? Well, in fact, we are kind of producing or emulating a water production plant with a local one, the big plant, some remote sites. And while in the local one, we see it quite big. You have, besides the water purification, the water tower, the pumps for the injection, you have that here and here too. We also have a crane for the chemical stuff to load and unload trucks. We want to make a nice demonstrator of it. And in fact, last Friday, we connected between Ghent and Lille as test. We could see via Skype and the camera that indeed the water is pumping or not pumping via the Profi Cloud. So from now on, we are quite home free. What do we want to do in the project? Analyze and demonstrate the working principle. Give comments to the developers in Germany. We have a very well listening ear since we gave them some tips already. And we would like to discuss with them for certain ways to do diagnostics in the communication at the other side of the connection. They didn't plan that. Nobody planned that in all those clouds. If you have something at the other side of the cloud, how the hell can you see what is wrong there, the diagnostics? It's very important in your local Profinet network, but also at the other side. If you only see China is down, okay, yeah, well, you need to know who is down, which component. So we will make a kind of large interregional demonstrator. We will generate, that's also part of the project, parts of the code. We will be generating it from MATLAB Simulink models and then just go to production code for the crane control, for example. And we will develop mobile HMI on Android devices for it. So that we have a nicely working demonstrator with webcams on every place so that we can really see what is happening. Otherwise, you have to believe us. That is it, in fact. Do you have any questions? Yes? Okay. That's a very good question. The components themselves, the hardware, is a low price. Really, it's the same order of magnitude as an I/O device. The other components you already have, your controller, your programming software. The cloud, the use of the cloud itself is a system with credits. When you are connected to the cloud, it counts down. And if you come to a next event, I will try to tell you how many credits we are using now that we have a larger application with some devices in the cloud and a cloud. I'm curious myself how many credits we will be using per 24 hours. It's operated by Phoenix Contact, but the host is IBM in Frankfurt. So one cloud coupler is your gateway to your cloud, and you can add quite a large amount of I/O devices to it, all at the same. So it's only between that cloud coupler and the cloud that you pay your credits. There is a practical limit, but normally in your Profinet network you won't reach that one. And if you have multiple clouds, like we have, we want to work on ourselves, not only with the NIF-Lil1 or ICAM or UK colleagues. We want to do tests on our own or connect, then you need, each time for a connection, you need a cloud coupler. Order of magnitude of price, if you don't get any reduction, it will be for a cloud coupler something like 800 to 900 euros without VAT. No, for the hardware, sorry. For the hardware. I really need to check. I would need my PC for that, how much we would have to pay for our credits, because in fact we got them like this as testing guys, but the price is not so high. I think it's something like 80 euros for 100,000 credits, but I can't make the link yet between the two. And they keep a little bit silent about it for the moment also. I could tell you that there are a number of running industrial applications for the moment, and in 1 or 2 weeks, one of them will officially come out. It's a Swiss company, I'm allowed to tell it to you, producing candy, Ricola, maybe you know it. They are already using applications in the cloud. There are a number of other ones, and there are in a few countries, for the moment, they are starting to have big applications. Maybe the biggest one will be in Belgium, but that one I'm not allowed to tell you. But that one would be extremely big, in fact.
But you are carrying a lot of data.
You're not carrying a... You are not transporting a lot of data because the update is quite slow, and it's just like in Profinet, only a few measurements or a few commands sampled very slowly. It makes no sense to go quicker because the update time is, for the moment, 500 milliseconds. So the amount of data is not so much. I interrupted you, in fact, you were going to ask. It's hundreds of milliseconds. It's over the internet. Nobody can do it quicker until we change the internet itself. Might be that TSN thing, but then you would need to route with only TSN switches and routers. You won't find that now. And for the rest, it's waiting until something else. 5G won't bring it to you. We still need something more than that. But there is research going on for that. I saw two people nodding when I said the tactile internet. They are the tactile, you can touch it and it's like you feel immediate reaction. They are doing research to go to an internet that has reaction times for dedicated traffic as fast as it can go, meaning limited by the speed of electromagnetic waves in copper or optical fiber. So that means you could reach Australia very quickly. But that isn't there yet. But that's in the pipeline. And then you could go to, if you would want that, I wouldn't know personally why, but if you would want that, you could do control very quickly. But to be honest, I don't see why. Local is safe and best. Well, as long as, is the camera running? As long as it's not Donald Trump, I would say, well. Controlling, keeping an eye on it, keeping an eye on key performance indicators. If you are the main plant of a company, I think they do that, but in a slower way. This is more direct, of course. But remote control for certain not. I don't see why, to be honest. It's a very long, yeah, but it's the connection which is, you risk going to your fail-safe state quite a lot of times, to be honest. So, faster than that, no, for the moment. That TSN thing is coming. That could be something which is more vendor independent. And for the rest, you keep with your times like they are for the moment.
Can you say more about the security of the network?
The security of the network itself, the connection is TLS encrypted. And you have the standard authentication procedure like you have with many applications. It's RFC, I forgot the number, but it's your standard protocol. For that also your bank is using, for example. It's the same thing. If that puts you at ease, I don't know, but it's something where you probably can't earn money, or difficult, as long as there's no control involved. No questions anymore? Yes? Mm-hmm. You mean the controller itself? No, that one stays on. It has to. Mm-hmm. Yes, we are for the moment busy with all the typical components. There are not so many different types. For each of them, what do they use during standstill, and what do they use when improve energy mode. And then we know we have there 3 use cases that I mentioned. There are so many drives, so many this, so many that. You could make a calculation if you have access to their pause times. So the idea is to time of life in the sense of mechanical, but if you stop and you stay under power, you're also standing still. It's the same mechanical deterioration. You don't get a gain there. The gain you get is that normally you should start up your plant or your production cell without any problem because it wasn't totally powerless. And when you put it without power, then you're guaranteed to not be producing cars. I could tell you that more than 10 years ago, somebody high in Volvo decided to say, we're going to save energy. This weekend, you're going to shut down the production line. They all looked, but okay, the boss is saying it. On Monday, they didn't produce cars, of course. You can't start up a plant. So this should be a way to start up a production cell or a production line quite smoothly because it was never gone. Okay.